Lesson 73. Starting from this lesson, we will be looking at specific techniques that you can use in integration questions. From the investigation, you have explored what the reverse chain rule looked like. Looking at the reverse chain rule here, integration by inspection requires you to recognize certain form in a function that is being integrated. The form of the function that we're looking for involves f prime of g of x multiplied by g prime of x. If this is the case, then you know that the result of the integration is f of g of x plus c. Let's take a look at example 1a. Find the following integrals inspection. A. When you observe this particular function here, do you notice the connection between the denominator and the numerator? If not yet, I'm going to help you out. I'm going to let u to be x to the power of 4 plus 3x plus 2, the denominator. What is the derivative of this function? The derivative of this function, I'm going to call this du. I'm going to write dx on the other side though. 4x cubed plus 3. Although the notation du by dx is not thought as a quotient, it's beyond the scope of this course, so I'm not going to explain too much about it. But for the purpose of taking integrals, you can write your work in this particular form, because it should make it easier for you to match up with what is seen in your question. What does this mean? So now I can actually put in 1 over u and then replace the light blue blob with du. And clearly we know that the integral of 1 over u is ln of the absolute value of u plus c. And now let's back substitute. We have ln x to the 4 plus 3x plus 2 plus c as a result. Question B. We're looking for the integral of 2 to the power of x minus sine x e to the power of cos x dx. We can first separate the two terms into two integrations. Okay. Now the first term, you should recognize that there is a direct rule for integration that we can use, which is 2 to the power of x over ln 2. How about the second term? What do you recognize? Is part of this function a derivative of some other parts in this function? I think so, right? If I let u to be cosine x, then du is sine x dx. That's good, because then I can replace these parts with the substitution. Minus, I'm integrating e to the power of u du, which I know how to do. 2 to the x over ln 2 minus e to the u plus c. And then finally, let's sub back in. For u, we have cosine of x plus c. Question C. Here we're trying to integrate cosine 4x over 1 minus square root of 2 sine 2x dx. If we try to follow what we did in part 1, is the derivative of the denominator the same as the numerator? The answer is no. What if you take the derivative of the numerator? Does it give you the denominator? I don't think so either, right? And also cos 4x, sine 2x. The angles don't really match. Let's get creative. I see 1 minus root 2 sine of 2x, which is half of 4x. So it prompts me to think, well, maybe I can relate this to double angles. Let's try to write cosine 4x using sine. I will have 1 minus 2 sine squared 2x over 1 minus root 2 sine 2x. Now what? I don't see root 2. I can't reduce. But what if I factor the numerator? You're like, what? I can't square root 2. Well, yeah, you can. Just write it as square root of 2. So the numerator, if I treat it as a difference of squares, I will have 1 plus root 2 sine 2x times 1 minus square root of 2 sine of 2x all over 1 minus square root of 2 sine 2x. This way, I can simplify. And it turns into the integral of 1 plus square root of 2 sine 2x dx. And so I know the integral is going to be x for the first term plus the derivative of sine 2x is negative cos 2x over 2. So I need to change this into negative root 2 over 2 plus c. Here is the next question, D. We're looking for the integral of 1 over 5 to the power of x. So in a way, I'm thinking of this question as the integral of 5 to the power of negative x. Looks close enough to the exponential function that we're familiar with, but not yet, because instead of having a positive exponent, I have a negative exponent. So if I let u to be negative x, du would be negative of dx. And I have negative of 5 to the power of u du. The integral of this is 5 to the power of u over ln 5 plus c, back substituting. I have 5 to the power of negative x. You know what? Let's write this as 1 over 5 to the x ln 5 plus c. And here is question E. Here we have integral of x over x plus 2 minus sine x dx. Okay. Now I notice that the second term here is easy to integrate. So I will first split up these two terms. Okay. Taking a closer look at the first term, x over x plus 2, when I take the derivative of x plus 2, it doesn't give me x. So I can't apply that reverse chain rule here. What can I do? Sometimes you need to be bold. You have to pave your own path by coming up with a way to decompose this rational expression. If I add 2 and then subtract 2 from the numerator, I did not change this expression. But what it does is it will allow me to break this down into x plus 2 over x plus 2, which is 1, minus 2 over x plus 2. And then I can take the integral of sine x, which is negative cos. So this is plus cos x plus c. Now, focusing on the first integral of 1 dx is x, minus 2 over x plus 2 dx plus cos x plus c. The good news now is that if I let u to be x plus 2, I know that du will be dx. Let me keep cos x in the front. We will be integrating 2 over u du plus c. Okay? Now I know that the integral of 1 over u is ln u. I'm going to substitute u, which is x plus 2, back here. And we are done.